Hello, Yaser. How are you?
Hi, I'm doing well. How are you?
Yeah, I'm good. And hi, Corey.
Hi.
Yeah, please could you introduce yourself first, and then we'll start with the conversation on a candid note.
Sure, absolutely. I'm Dr. Yaser Maddahi, the president and CEO of Tactile Robotics. I've been running this company for more than 3 years, working on different high-tech products and solutions for different fields, including health sciences, dentistry, and rehabilitation.
Wow, amazing.
Yeah, and my name's Corey Weir. I am the business development manager here at Tactile Robotics, and I've been here for just over half a year, and been able to kind of see Dr. Yaser in his prime here as he really brings a lot of our ideas to fruition. So.
Wow. Great to know you guys. And what I see is that you're quite a tech-driven person and you carry a lot of potential of helping, the medical professionals, and especially with these times of the pandemic, which is there. I read about you helping the dental colleges and I was really intrigued, because looking at the situation today, education and imparting education and then practically actually doing it hands-on, which we considered is getting difficult. And that's what I see you guys doing it. And I would like to know more about that. So, Dr. Yaser, can you share a little about yourself, your journey to opening the company, and then, of course, your child, as you said, DENTEACH?
Yeah. Actually, I would say this is my first child. I have 2 more physical ones, the live ones, but those are considered as second and third ones.
Okay.
So I came to Canada in 2009 to do my PhD in mechanical engineering in robotics and haptics. So when I was doing my PhD on teleoperation, so I learned how to control things at a remote distance from a remote location. So what I did for my project, I developed a platform. I'm not sure if you know about this city, Winnipeg, that we are living in. We have experience plus 50 here and minus 52. Each year we do experience these two, like 102 degrees difference. So
oh my God.
if I was a mechanical object, I would crack like plus 50,
exactly.
minus 50. But luckily we are human and we can adapt our bodies. So that's not a big deal. So one problem that we saw here, live line engineers and linemen, what they do, they have to go outside the city, which is windy, which is like minus 40, minus 50. They have to go up on top of the crane, the bucket, and do maintenance, de-icing, changing the insulators, and many live line maintenance actually work, which is dangerous, which is less safe, and which is difficult to do.
Definitely.
So the idea that I was working on was that what if we have a robot, instead of the human on top of the bucket, like 30, 40 meters above the ground.
Yeah.
So instead of the human, one robot can do that. But the robot needs to be controlled, right?
Exactly.
That control could be done using a human. That could be in their office, in a warm place, or inside the van, inside the truck, actually to be done by joystick. And the joystick we use is called haptics. Haptics is like sense of touch. So this is how it works. So you have a robot on top, and you have a visual on that robot. So there are cameras, you can see how the task completion is going. And there is a joystick or haptic device that you can control the end effector, the end point of the robot. So you can move the robot from point A to point B. You can attach a tool to the robot and ask the robot to tighten a nut, for example, to change the insulator, something like that. Okay. So this is called teleoperation.
Wow,
and this
nice.
is remote operation. And it
Wow.
could be done when you are in your office here, when you are closed inside your car. This is the concept of Internet of Things. This is the new industry generation that is called Industry 4.0.
Yes.
So I completed my PhD, so published 8-9 journal papers on that. And after that, I was hesitant to go for industry or for academic.
Either ways.
So I received a very good scholarship at the University of Calgary. I did my PhD at the University of Manitoba, Winnipeg here.
Okay.
So I did my postdoc at the University of Calgary. In 2013, after completion my PhD, I started my postdoc on January 2nd of 2014. And I went there to learn about surgical robots and working on robotic surgery. This is the title of my postdoc. So I was working in a center that is called Project NeuroArm. And what is NeuroArm? NeuroArm is the only robot-assisted neurosurgical system that is used in the world to perform neurosurgery on real patient, not 3D printing, just real patient. And so far, it has done like more than 60 successful operations.
Wow.
Brain surgery, you can see how delicate is that, how accurate is that.
Precision, yeah.
Yeah, everything. And the most important thing that we need is haptics.
Yes.
Because you need to feel how much pressure you are applying to the skull, to the bone, to the tissue, to the tumor, which has like different softness than the regular brain tissue, those things. And this was the parts that I was dealing with. And as part of my project, I was developing an MR compatible haptic device. Imagine, so when you are inside the MR room, what patients do normally for functional MRI, I'm sure you're familiar with. So this is how it works. They want to ask the patient to think about some words or to do some activities, and they want to actually study different regions of the brain. Yeah. So, but this is all about audio. They listen to something. They look at a photo, they look at the word, and they just try to think about that. But what if we have a patient and we ask the patient to do some physical tasks?
Yeah.
What if we have a robot, we have a device that is totally MR safe, MR compatible, and could be operated inside the MR machine that, that's crazy, high magnetic, and it's very sensitive. So you should have sensors in it. You should have wires in it. You should have actuators in the MR machine. So you need to investigate compatibility and safety of each single component inside the MR machine. So that could help the patients to actually perform some given tasks. For example, pick a ball from here and put it there. Is there any ball there? No, it's all virtual reality, right? What you see, you just see on a screen that is MR compatible again, that you need to hold this haptic device and pick the ball, and after that, place it on the second position. But all the forces that is applied to your hand in a real situation, that is applied to your hand by the haptic device.
Right. Haptic comes into play, all the tactile sensation, right?
Exactly. So I'm here that you connected to Tactile because I want to talk about Tactile Robotics and connect my story and journey to the
I'm getting there. Yeah, I'm trying best in getting there.
Yeah. So I was fortunate to get the most prestigious postdoctoral award in Canada.
Wow.
It's called Killam Fellowship. So they call us like Killam Laureate. They believe that this is something prestigious here, but I was really fortunate and blessed to get that. The year I got it, it was given to 5 people in Canada, and I was one of them.
Oh, wow. Congratulations today as well.
Thank you very much. And I kept working on robotic surgery and actually fMRI haptic device. And at the last 2 years of the project, I was thinking, okay, what did I do in Canada when I came here? Did I have a specific reason, or I just came here to just spend time and I don't know, get my permanent residency, citizenship, something like that? And the answer was no. There was a reason you came here. If I saw everything that has been planned for me, I worked on robotics, haptics, teleoperation. I worked for lifeline maintenance in industry. I worked teleoperation for robotic surgery, the unique platform in the world. Everything is about remote operation. And then I had an idea. What if we just increase the distance? What if we take it to the space?
Wow.
Not moon, not Mars. I'm talking about something that is useful for a human. So I was, I wrote a proposal on robot-assisted space telemetry. We call it RAS. And the proposal was funded at the University of Calgary. So the idea was that the surgeons are in Calgary or anywhere in the world, and the astronauts in International Space Station, there is a robot over there. The surgeons can control the robots, and the robot does real surgery. So of course, this is not a 1 year, 2 year project. That's a like 20 years, 50 years project. But the idea was that we had to investigate if this is feasible or not, if we can do that or not. So we started collaboration with the University of Manitoba here. We have a communication champion, Dr. Hussein here. So we started working. We hired 2 master students to develop a code because everything related to space is classified. Can you get some information about something? NASA? No. Canadian Space Station Agency? No.
Nothing.
So CSA? No. Everywhere? No. European Space Agency? No. So is there any published paper on that we could get? No, because those are like the outcome of 50, 60 years of research, high-tech research. They are not going to disclose the information, right? So what we did, we tried to with those 2 students that I was co-supervising, we tried to develop a program. That program is emulating the communication network between here, the planet, and the International Space Station. And this is not like neuroarm surgical system or lifeline maintenance robotics. Because the point is that the robot that is supposed to be in the ISS, it's not stationary. The ISS rotates around the Earth, right? And this is not just a circle. It has a sinusoid movement. So it's crazy. When I was working, we noticed that we have a blind spot of about 10 degrees out of 360 degrees that we cannot communicate. So what if you are in the middle of a surgery? I'm not talking about brain surgery.
Yeah, just it could be any
simple
surgery.
Operations. Yeah, because everything that is very simple, it becomes emergency there, right?
Definitely.
Even a tooth, something like that. I'm talking about like doing a micro manipulation task, not a real surgery, because that's soon for now, and there is a long way to reach that point.
Exactly.
So we emulated that, and the software, after it was done, we could actually ask expert to validate that, and it was very, very close to the real situation, because we considered several parameters and tried to be realistic. Even we considered the density of air, the temperature, the change, everything. We tried to consider as much as our knowledge actually allowed that time. So we tried to incorporate all of those parameters. That was another experience. So what we did, so from Manitoba Hydro, which is a like less delicate task, and then robotic surgery, and then International Space Station.
My God.
So
it's like
if I wanted to follow that, the next station should be Moon and Mars, right?
Looks
but
like.
For me, the next station was Tactile Robotics.
Okay. Oh my God. But I was wondering now, definitely it's going to be Moon that you're going to tell me about.
No. So this is what I did. I decided to use my little experience that I had to something that is helpful and useful for our community here, right? Wow. When we talk about like teleoperation, robotic surgery, ISS, those things, those are high-tech actually industry, I would say. But can I serve like public with that?
Not really. Not huge.
Not as much as I want, right? So I decided to have my company here. And during our postdoc, we had a company actually there. I was the shareholder and executive member there. So I could learn some business part during my 4 years of postdoc. So I was a combination of business person and a researcher, which is difficult because I would say they both are opposite.
Exactly.
So you can publish a paper or you can earn money. And when you are a researcher, you are shy enough to go out and sell something and ask for money for the business, right?
Exactly.
But I think I could make a right decision to go for an R&D company, a high-tech company. And the first product that we started working on came from, the idea came from my wife.
Oh,
so my
wow.
Wife my wife actually started dentistry here. So the way they were taught in the classroom, she was not happy. And she was complaining all the nights that she was coming home. Oh, I don't understand. Why should I just gather around the instructor and the instructor puts a jaw on the table and try to use the drill to do something? Oh, I have no clue how much force or pressure she's applying or how I need to handle the tool, because that's very important as a dentist. That could be a lifetime health problem for you. You need to know how to work with mirror, with handpiece. Even that part is difficult. Like you are standing in front of the mirror, you are trying to cut your hair.
So you have so many jokes for dentists because of the reason.
Yeah.
That's the reason you have them.
Yeah, I think, that was the first actually idea that we tried to work on. We started, this is the only part that we are similar to Apple. We started from our basement. We worked there for a year.
Wow. Nice.
Yeah. And we started like more than 3 years ago. So I want to stop here. I can talk for like another 2 hours, but maybe you have specific questions about company products or how we help.
I would like to know definitely the products that you have, which can actually help patients, help doctors actually execute technology, because this platform was basically for 3D printing as a technology, and I wanted to know what are the other technologies we can associate together and actually help patients. Because my focus is also around the patients, and like you said, a researcher and business acumen both together, it's a little difficult, but let me tell you, I am at the same point at the moment. So I don't know where am I going, but then I definitely know that the combination that you talked of, I'm at the same level of combination, but I don't know where am I going ahead with this.
And that's a very, very tough decision.
Yeah, it's very difficult.
You know, when you see that you have spent your life at university, research labs, you have published like 70 journal and conference paper, and you are ready to be a university prof. And suddenly you decide to go to do real job.
Exactly.
The real job. I mean, all the research, everything at universities, they are wonderful. But we need to investigate how much they have impacted the human life, actually, right?
Yeah, that's what came to my mind.
It will impact, but it takes time.
It takes a lot of
Because
time.
as part of your mission, you need to graduate the students, you need to wait for governmental funding. You cannot have private funding to expedite the projects. One project may take like decades.
Exactly.
So
it just goes on and on and on.
Yeah. And another thing that you see in research at universities is perfectionism.
Yeah.
They try to increase the accuracy from 99% to 99.5 and 0.56 and 0.6, 0.7. So, you know what? Even 90% works because there is not such technology out, right? So let's start with 90%, then we will make it 95, 99. That's fine. That's why I noticed that perfectionism is the enemy of success.
Yes, it kills your innovation. It just dies because of that perfection if you just go after it.
Yeah, exactly. And the reason that at universities they can be perfectionists, but in business we cannot, that they have free money to spend, but we have to pay from our pockets. So we try to take it to the market.
Yes, and you have to work and create money. So it's like, doing both the things together. So you have to have the researcher's mind and the acumen of the business person. So it's a difficult situation.
Exactly. You're right. So let me talk about two main actually directions that we are going to. So we are helping patients for sure. And at the other side, we are trying to train better students.
Okay.
So the problem that we solve with the dental platform, this dental platform is called DENTEACH. So a platform that is using for teaching in dentistry, DENTEACH.
Yeah.
So this is the idea. So we call it tabletop platform. So teaching method, you have the jaw here, the lower jaw or upper jaw. You just put it on the table, and instructor tries to teach the student how it works.
Okay.
There are 3 techniques so far. First, the instructor puts that here, and there are groups of students, a group of 10, let's say. They just gather around the instructor, and instructor is working with can I have the pen? The instructor works with the handpiece. And this high-speed handpiece, low-speed handpiece, and try to do a prep, for example, for this student.
Right.
And the students are just watching. And depending on the angle of their view, the perception they have from tool handling is different, right?
Okay.
So I should hold it like this. And the other one says, I should hold it like this. And this is not real, right?
Okay.
Another thing is that how much pressure you're applying to this. Are you applying enough pressure to avoid rework?
Exactly.
Or you are applying excessive pressure. So a simple filling could
turn
be
into
endo.
A perforation,
Yeah, could be endo. So
exactly.
It's very important to have some idea about this, right? And another thing that if you put your upper jaw here, it means that the patient is upside down.
Upside down, exactly. So that's another consideration, Yeah.
And another thing is that when you are working here, when the student is here, do you have a proper view on the tooth? No, the hand and the handpiece, they are blocking your view. That's why you're trying to change your...
Yes, everybody's hinging around,
right? Exactly. So there are 4 problems that we solve.